Here are your lesson notes for section 2.3. Still looking at part of the quadratic formula that we were looking at in our last lesson, but today's focus is just on the discriminant, which is just this piece that's under the radical. So that's what you're seeing right here at the head of the notes, just identifying what the discriminant is, the b squared minus 4ac. We're using this symbol in the notes to represent the discriminant, just for abbreviation's sake. But just a couple things for what this discriminant tells you. The gist of the notes is basically if you get a positive number under this radical, which is normally the case when you're solving a quadratic, if your number under here is positive, then you're going to get two different solutions for your equation that you are solving. Because of the plus and the minus, you get those two different solutions. If the discriminant is 0, well, whether I add the square root of 0 or subtract the square root of 0, I'm going to get the same solution. So they still consider that to be two solutions, but it's two of the same solutions. And then the third option would be if you get a negative discriminant, so a negative result under this radical. Well, we all know you can't take the square root of a negative, so there would be no solution to that case. So here's an example for each one of those cases. So starting with the first one, this one is the normal case where you typically get a discriminant that's positive. So you get a discriminant that's greater than 0. So if you were to take this quadratic setup right here where a is 3, b is 4, c is -1, if you were to solve all that, this is what you would get if you did the entire quadratic formula. But just the 7 right there is all we're concerned about for this section. That 7 would be the discriminant for this problem. Because it's positive, you would get two distinct different real roots. So these are two different roots compared to in the next one where you're going to see two equal roots. Here's a good graphing example for you on the right for why this is the case. Keep in mind that for this quadratic, because we always set them equal to 0, we're basically saying what are the x's where y is 0. So if you look on a graph, well, where is y 0? Everywhere on the x-axis you have a y value of 0. So for a case where I have a positive discriminant, meaning I have two different real roots, that means my parabola would hit the x-axis in two different places. So this is why I have two different real roots. Look at the next one. So here's just another quadratic setup. But if you were to do quadratic formula on this, and really just specifically the discriminant, you can see that the discriminant for this one is 0. So if I am adding 0 or subtracting 0, I'm going to get the same solution either way. So this one would have, they still refer to this as having two roots, but they are two equal roots. So it's just the same root repeated twice. And that would just be a case where you would only have one x-intercept. So here's the third scenario. Here we go. So here's a scenario where you have a negative under the radical. So if your discriminant is negative, then that's just going to be a case where you have no real roots. Like this graph here, you can see there are no x-intercepts, so there would be no roots. So if asked to describe or to work with the roots or the discriminant, don't do the entire quadratic formula, just do the discriminant. So you're just doing the b squared minus 4ac to work with the problem. So in this case, because we got a discriminant that was greater than 0, we know this has two distinct real roots. In a case like this one where you get a negative, so if your discriminant's negative, then we have no real roots. And this last one's a biggie, so you want to pay close attention to part C. This is a real typical test question, IB question right here. So looking at this one, you can see that the A value is k plus 4, the B value is 6k, and the C value is 5k. In this problem, this is your key right here. It says it has two equal roots. Well, what does that mean for a discriminant where you have two equal roots? So if you remember back up to what we saw right here, if I have two equal roots, that only exists when the discriminant is 0. So if I perform the discriminant formula on this, I can set it equal to 0 because of that statement right there. So plugging into b squared minus 4ac, setting the whole thing equal to 0, because it says it has two equal roots, then all you have to do from there is solve the equation. So you're looking at a quadratic, you're just solving that with any of our methods for solving, factoring in this case. So you can see based on this factoring process that k could either equal 0 or positive 5. Either one of those answers or both of those answers would be accepted. So 0 or 5 would be our two solutions for k. Keep in mind that 0 and 5 are not solutions for x on this quadratic. They are solutions for k that would create cases where you would come out with two x's that are the same. You could plug them back in and actually get your solutions for x if you wanted to go that route, or if we needed to go that route. But in most cases, this is really where that one's going to end, is just solving for k.